Hello, today we're going to be learning 9.4, which is about the unit circle. So first let's talk about the angles on a coordinate system. So typical lowercase Greek letters used for angle measures, which is theta, alpha, beta, and gamma. And we can see here we have our circle, we have our initial ray, our terminal ray. So our initial ray is the first one, and it's the standard position of an angle. So some sample standards of positions, we have it here, and as you can see, this bottom one is going all the way around and back over. And so the initial ray, that's right here, that one is always going to be in that position. So when we talk about angles, the initial ray will always be along the x-axis, as we can think about it, right? Because we have this coordinate system, we have the unit circle on it. So the first one is always going to be on the x-axis going right. So for all of these, they will always be like that. So right there, here, and here. Okay, let's go ahead and talk about the degrees. So we have 45 degrees for number 1. So if we think here, this is going to be 90, right? That makes a 90-degree right in that corner. So 45 is halfway between there. So I want to go halfway between, which the slope is going to be up 1 over 1, right? Because that's halfway between the y-axis and the x-axis. So right here, we would have 45 degrees. Now, if we take a look at number 2, that is 120 degrees. So 120, that is super close to 90, and it's also kind of close to 180. So it's somewhere between that, right? So remember, 180 is going to create this straight line. So this whole thing would be 180 degrees. And so I want 120. So I'm going to go ahead and subtract 180. Or 90 and 180. So what that's going to do is going to tell me about how far down is it going to go from 90 to 180. So 120 minus 90, that's going to give me 30 degrees. So that means from my 90-degree position, 120 is only 30 degrees away. So let's say that's approximately, it's not going to be quite half, so it'll be about right there. So now, let's go ahead and erase all these extra marks. We have this area here, which is 120 degrees all the way over, right? Because it's past 90, and I did the subtraction to try and figure out, okay, about how far. So this right here is 30 degrees. And then that would mean this here is 60 degrees. So all of these numbers are going to be correlated from one another as we go around this unit circle, but on a coordinate system, right? Okay, let's go ahead and take a look at number 3. So number 3, we're going 270 degrees. So I know that is past 180, so I know it's going to go past this way, but I'm not quite sure how far. Remember, in a circle, an entire thing is 360 degrees. So all the way around. So if I start and end in the same spot is 360 degrees. So what I'm going to do is take 360 and subtract 270. And that's going to give me, sorry, that's sideways, 90 degrees. So that means there is 90 degrees until, sorry, I just want to make that a little bit nicer. Until we hit 360 degrees, there is 90 degrees left, which means it'll be here. So we have that 90 degrees left over, and so our angle for 270 degrees goes all the way to the negative y-axis. All right, and then now with number 4, we have negative 30, so that just means we need to go in the opposite direction, 30 degrees. So once again, 30, it's not quite half. Remember, half would be 1 over 1, because that's halfway between the two axes. So 30 degrees is going to be a little bit skinnier than that. Let's go ahead and take it about there. All right, and then our arrow would go this way because that would be negative 30 degrees. So positive, you're going up and to the left. Negative, you're going down and over. All right, let's go ahead and go to the next page. So the unit circle. We want to draw a circle with radius of 1 and center at 0, 0. Find the ordered pairs for the endpoint of the terminal ray at the following angle measures in degrees. All right, so let's go ahead and first talk about the endpoints on the axes. So we have a few of them right here. So this first one, remember this is at 0, 0, right, that coordinate point, and the radius is 1. So that means this whole piece going all the way over here is going to be 1. But it's 1, 0 because I'm not going up or down at all. Okay, let's talk about on the y-axis. So once again, it's at 1, but it doesn't move left or right. So 0, 1. And then over here off to the left, it's once again going over 1, but it's in the negative direction, so it's negative 1, 0. And then down here at the bottom, once again, it's 1 away, but it's in the negative, and we're not going left or right at all. So those are good coordinate points to remember. Okay, let's go ahead and talk about the degrees now. So the degrees are in order up top of your paper here. All right, so let's go ahead and label what those are. I'm going to erase the center here. The first one that we have is 30 degrees. And then as we go around, I have 45 degrees, 60 degrees, 90 degrees. And remember, all of these correlate with our starting ray. So that's how far each of these away from our starting ray. Okay, let's go ahead and finish drawing all these out. So I have 120 degrees. Let's see, 135, 150, 180. We have 210, 225, 240, 270. And we're going to have 300 degrees, 315. Oh, these spaces are so tiny. 315 degrees, 330 degrees, and this last one will be 360 degrees once you get all the way around. It's also important to recognize too that if we aren't going anywhere, that is 0 degrees. So you start at 0 degrees and then you go all the way around until you get around your circle to get to 360 degrees. All right, and if we were to dissect these, we are doing either 45, 90, 30, or 60. So if I just take each quadrant, let's go and take this bottom quadrant here. I know that this is 30 degrees right there. And then we have 45 degrees, and we have 60 degrees. And then, of course, all the way around, I did not give myself enough room for that, 90 degrees. So it does go in that order, 30, 45, 60, 90, all the way around the circle. So I can start from any quadrant and just know that. Okay, the first line is 30 degrees away, second line 45, next line 60, and then all the way to the axis is going to be 90. So even though I have some pretty big numbers here, and you might be thinking, how am I supposed to know any of these? Well, when you're given an angle measure, you can use the advantage of, okay, well, it has to be 30, 60, 45, or 90 degrees away, and you figure out where it lies on your axis. All right, let's talk about the coordinate measures now. So it's not going to be as simple as, oh, well, it's 1 away because the radius is 1. The radius is still 1, but since it's around in a circle, it isn't going to be just a nice clean number. So we're going to have to figure out what that is. I'm going to go and draw a line straight down, and I have now created a 90-degree triangle, or a right triangle. Okay, this is a special right triangle, so 30, 60, 90 triangle. Let's go over the ratios of that one more time. I know we did that a couple days ago, but let's go over the ratios. So we have 1, 2, and 1 root 3. Actually, let's go ahead and put x. So this will be 2x, x, and x root 3. So whatever number that is, we just plug it in and figure out what it equals to. All right, so my x and my x root 3, that's how far I'm going right, and that's how far I'm going up. The only measurement I know is my radius. So I know that this is going to be 1, because that is the radius, and we have been told that the radius equals 1. So for all these lines, we know that they all have a length of 1. All right, since that is 1, in order to find x, I'm going to go ahead and say that 1 equals 2x. So if I go and divide by 2, I'm going to have 1/2 equals x. So that gives me this length over here, 1/2. And then, since it's just x times root 3, I know it's going to be 1/2 root 3, which we can go ahead and just write that as a fraction, root 3 over 2. So remember, this is going to be my x, and then I have my y, and those are my coordinate points. So my x going over is root 3 over 2, and my y going up is 1/2. All right, let's go ahead and try that again with the 45 degrees. So that we don't have to erase it every time, let's go ahead, I'm just going to draw the 45-degree triangle here. So we know this is, we have 45, so we have another special right triangle. Let's go ahead and just write the x root 2. So those are the ratios. I know that my radius is 1, and so I need to go from there. So I have 1 equals x root 2. We can go ahead and divide by root 2. Of course, I need to rationalize, so I have 1 over root 2. I'm going to multiply the top and the bottom by root 2. So remember, we do not want a square root in the denominator. So what that's going to give me is root 2 all over 2. And that is going to be my x value. So with 45, 45, 90, the two legs of the triangle are the same. So root 2 over 2, root 2 over 2. Okay, so now we know the coordinate points of the next one. Root 2 over 2, comma, root 2 over 2. Okay, and then let's go ahead and go over the last one, which is 60 degrees. So once again, I have my triangle, my right triangle. This is 60 degrees, so therefore this has to be 30. And I know that my radius is 1. Okay, so we have x, x root 3, and 2x. So once again, I'm going to set up, I know 1 has to equal 2x, and my goal is to find x, divide by 2, so I know that x equals 1/2. Now, this is very similar to my first triangle I did, right? My 30, 60, 90. Well, of course, they have the exact same ratios, but they're now in different positions. So as you can see here, opposite of my 30, I have the 1/2. I still have my 30 opposite the 1/2, but instead of it being the y value, it's now my x value on my x-axis. Okay, and then my x root 3, I can have 1/2 root 3, and then so that we just have a fraction, I'm going to say it's root 3 over 2. So now I have my coordinate points again, right? We go right and then up. So 1/2, comma, root 3 over 2. Okay, we have our first quadrant done. Let's take a look at some commonalities. So my first point and my third point, right, or not including on my axis here. So we'll have my first point and my third point here. I notice that they have the same numbers, but they're flip-flopped. right? So once again, we talked about we have 30, 60, 90 triangle. It's the same ratios, but the 30 and the 60 get flipped. So therefore, that makes sense that their x and y coordinates also get flipped. All right, that second point in the 45 degrees, both x and y are the same values. And once again, this one also makes sense because if we think about a 45, 45, 90, it is an isosceles triangle, which means the two legs have to be congruent to each other. So the fact that they are the same makes sense. All right, and then the nice thing over here, let's go ahead and take a look at the rest of our circle. Remember how I talked about all of these? We'll have 30, 69, or we'll have 30, 45, 60 all the way around. We can continue to make these triangles on this side. So if I were to start up here, there we go, and I were to make my triangle there, I would know that this whole thing here is 60 degrees. Right? If I really wanted to, we could go this way, but we'll continue to just go up and down. Okay, so that is 60 degrees. So once again, I have my 30, 60, 90 triangle. Since that is 60 degrees, I know it's going to relate to my 60 degrees over here. We should end up with the same values, but there's one thing. Remember, we are on a coordinate plane, and we are in quadrant number 2, and so that means our x values are all negative. So that means I should have a negative 1/2 and then root 3, 2. All right, next I have my 45 degrees. Remember, it's an isosceles triangle. Both the legs are going to be the same. It's going to be the exact same as the other one. But remember, we are in quadrant 2, so that means our x value should be negative. Okay, and then we have my next one over. This one is our 30 degrees, so it makes sense that it matches with my 30 degrees on the other side, but with a negative x value. All right, and then we can continue to do that around the whole circle, but this time I'm going to be making my lines going downwards towards the center, right, to create those triangles. So let's go ahead and write these down. We are in quadrant 3, so that means both of my values are going to be negative. So I'm going to have a negative root 3 over 2, comma negative 1/2. And then the next point down, negative root 2 over 2, comma negative root 2 over 2. And then the next one down, negative 1/2, comma negative root 3 over 2. And then once again, same thing with our next quadrant. So my next point, this one, my x's are positive, but my y's are negative. So I will have positive 1/2 and then negative root 3 over 2. And then we'll have positive root 2 over 2 and a negative root 2 over 2. And then our last one, positive root 3 over 2, and then a negative 1/2. That kind of went right next to my triangle. Okay, so there is our unit circle. We have the degree measures going all the way around. And don't worry, I'd probably say the important ones are the first few, so 0, 30, 45, 60, 90. And that's just remembering that all of them also go by 30, 45, 60, or 90. And so you can use that to help you. For the 90 ones, you could probably remember 180, 270, and 360. But if you just remember 30, 45, 60, and 90, and just know that it continues that around the entire circle. All right, so how do the coordinates that you found compare to sine and cosine of each angle? So let's go ahead and take one of these triangles I drew since I erased the 45. Actually, let's go ahead and do the 30, 60, 90 since it is on the triangle. All right, sorry, it's on the circle. The triangle's on the circle. All right, so first, let's go ahead and talk about sine. So sine of 30, We have sine of 30. That is going to be opposite over adjacent. So my opposite is 1/2, or sorry, not opposite over adjacent, opposite over hypotenuse. So 1/2 over 1, which is just 1/2. Okay. And then let's talk about cosine of 30. We have square root of 3 over 2 all over 1, which once again just leaves us with the square root of 3 over 2. Now these two values that it leaves me with, 1/2 and root 3 over 2, are my coordinate points, right? We have 1/2 and root 3 over 2. So this is how it's always going to work here. Sine will always be your y value, and cosine will always be your x value. So we can think of it as, we have our coordinate points x and y, but I'm going to think cosine, and we'll go ahead and use theta to show for our angle, so cosine of theta, comma, sine of theta. So cosine represents the x, sine represents the y. Okay, what does the tangent of each angle tell you? What happens at 0 and 180, and what about 90 and 270? So remember, tangent is opposite over adjacent. And then so we can go ahead and say that tangent is equal to sine over cosine. All right, so if we think about our equation here, if I did tangent of 30, right? So tangent of 30 is opposite over adjacent, which is the 1/2 over root 3 over 2. And we just talked about how the 1/2 is my y, so that's sine, and the root 3 over 2 is my x, and it's my cosine. So that's how I'm able to say, okay, tangent is sine over cosine. All right, so let's go ahead and check out these values. So I have tangent of 0. That's going to end up being 0 over 1, right? Because tangent of 0, we have x and y. So 0 and 1, that's going to equal 0. And then if we check out tangent of 180, that is also going to be 0 over 1, but this time negative 1, right? Because if we use that coordinate point, it's a negative 1, not a positive 1. But it still gives me 0. So I do have points there. Let's take a look at 90. So tangent of 90, when I'm at 90, my sine, which is my y, is at 1, and my x, which is cosine, is at 0. So we can't do that, so that's not something we can do. Let's go ahead and check out tangent of 270. So this time I have negative 1 over 0. Once again, something we can't do. So the tangent in 90 and 270 is undefined. All right, so let's go ahead and move on to the next page. So if we take a look, if you want to go ahead and visit this, and that's a good visual for the unit circle. Let's talk about this information here. It'll be the same as you see on the website. So a good way to remember these, because yes, that was a lot of numbers that we just worked with. But there's ways for us to remember them and help us start to memorize this unit circle so that we understand the pattern that's going on. So first, we want to think 1, 2, 3. So sine of 30 is the square root of 1 all over 2. So in other words, 1/2, because the square root of 1 is 1. So we've been writing this as 1/2, right? So we've been writing this as 1/2. But if we were to write the square root of 1 over 2, it would mean the same thing. All right, and then cosine goes 3, 2, 1. So remember, sine is all of our y values, and cosine is all of our x values. All right, so if we take a look here, our cosine, our x, it goes 3, 2, 1. And then once again, of course, the square root of 1 we can just write that as 1/2. So if you think 3, 2, 1 for the x, and then 1, 2, 3 for the y. And then when you start to come back down the opposite direction, I'm going to write down the x values. So we're going to have 1/2 root 2 over 2 root 3 over 2. So they just kind of keep repeating that way. So for my x values, I have 3, 2, 1, 1, 2, 3. And then as I continue around, I'm going to have 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. And then same thing goes with the y values. Let's go ahead and write that down now. So I have 1, 2, 3. I'm going to have 3, 2, and 1. Do remember, I forgot to write them down. Our signs do change, so you just have to remember which quadrant you're in. So you remember, is your x negative, y negative, or both? All right, so once again with the y's, we'll have 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. And it keeps going around like that. And then all of them are being divided by 2. So we just need to remember that they're all being divided by 2. And then we just have to remember, okay, 3, 2, 1, 1, 2, 3. Okay, let's go ahead and take a look here. So quadrant 1, a trig function with positive values, all of them. Quadrant 2 is sine, quadrant 3, tangent, quadrant 4, cosine. Okay, so those are going to be the positive values, but I would just, this is a good way to remember sine, tangent, cosine. We do have to start thinking of our x and y coordinates as sine, tangent, and cosine for all of those. But if you think about your quadrant, right, we have positive, 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 negative, 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 and positive, negative. I think I said the second quadrant incorrect, but that's how the quadrants go. All right, let's talk a little bit more about tangent. So tangent is opposite over adjacent, so sine over cosine. We talked about that. So you can calculate the value for each angle. So if I want to do tangent of 30, right, so sine over cosine, if we look back at the unit circle, my sine, which is my y value, is 1/2. My cosine, which is x, is root 3 over 2. So while you're doing these problems, have your unit circle available, have it open for you to look at. All right, so I have 1/2 divided by root 3 over 2. So that's going to be 1/2 times 2 over root 3. So now when that cancels, I now have 1 over root 3. I don't want my root 3 in my denominator, so if I multiply by root 3 for both of these, I'm going to have root 3 over 3. So there's the tangent of 30. Let's do the same thing for tangent of 45. I like 45 because they are the same numbers both times. You don't have to try and remember which one's x, which one's y. And it's just root 2 over 2. So once again, the same thing. If I am dividing these values, I can rewrite it here, and then flip my fraction so that it's multiplication. And the nice thing is both of them cancel, so that means the tangent of 45 is 1. And that's nice to know and remember. Okay, let's take a look at 60, our last one, tangent of 60. Remember, 60 is just going to be the opposite of 30, so I can take root 3 over 2 all over 1/2. So let's rewrite that, root 3 over 2 divided by 1/2. Flip the fraction, root 3 over 2 times 2 over 1. So that cancels, and I'm just left with root 3 over 1, so my answer here would be root 3. All right, let's go ahead and take a look at the next one. So examples, find the following values without using a calculator. Try to recreate the portion of the unit circle that you need rather than looking at the previous page. All right, so now instead of trying to look back and forth, and this will help with some memorization as well, trying to remember where everything goes. All right, so let's go ahead and start with the cosine of 135. So 135, I know is going to be somewhere over here. So if I take 180 minus 135, I know that my remaining portion here is going to be 45 degrees. So I know it was past 90, and I know we had to go to 180, so that means I have this 45, 45, 90 triangle. Well, let's go ahead and try and remember that coordinate point, so root 2 over 2 for both of them. And don't forget that negative. I keep forgetting to write it. There we go. Root 2 over 2. Okay, so cosine, remember cosine is the x value. So I want to find the x value, which is negative root 2 over 2. And there we have it. All right, next one, find the tangent of 330. That is 30 degrees away from a full circle, so I know that I have a 30, 60, 90 triangle. So my 30, 60, 90, I know I'm going to have root 3 over 2 first, and then negative 1/2, because we're in that fourth quadrant. I didn't draw all 4 lines, but we are in that fourth quadrant, so my y values are negative. All right, and I'm trying to find tangent, so remember that is sine over cosine, or in other words, y over x. So my y, negative 1/2 divided by root 3 over 2. So negative 1/2, I'm going to go ahead and flip it right away, 2 over root 3. So that cancels, and I now have negative 1 over root 3. And then when we rationalize, I'm going to have negative root 3 all over 3. All right, let's take a look at number 3. Find all possible values for the missing angle in the equation where the theta is between 0 and 360. So that means we're not going to be worrying about negative numbers, and we're not going to go past 360. So just in the single unit circle. So I have sine of theta equals negative root 3 over 2. So there's a couple things I want to look at, which is sine. I know that's going to be my y values. And then I have a negative symbol, so if we think about our quadrants, when y is negative, that's going to be down in these quadrants. So this is quadrant 3, and this is quadrant 4. So I know it's going to be somewhere down there. I also noticed that it's root 3 over 2, so I know it's definitely not going to be at the 45 degrees. So let's go ahead and draw our circle. So I know it's going to be down here somewhere. Root 3 over 2 in the y value. Remember the y's go 1, 2, 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. I don't think I drew those lines in the correct spot. Probably should have waited, but that's okay. So I have root 3 over 2, so I know I'm going to be here and here. This is just a draft. It's not going to be perfect. And then they're all over 2. So those are the 2 values that I know I'm going to have to work with. And so from here I can try and figure out what are those values. So that's going to be 270. I know it's 30 degrees, so therefore I'm going to take 270 and subtract 30, which will give me 240 degrees over here. And then if I take 270 and add 30, that will give me 300 degrees over here. So to get the sine of theta, there's 2 different options in order for me to get negative square root of 3 over 2. All right, let's go ahead and take a look at examples 4 and 5 and try these ones out. So once again, we want to do it without a calculator. So we'll take a look at a few things. Sine of x, so remember that is y. And then we have a positive 1/2. So positive, this will be in quadrant 1 or 2. Right, so one of the 2 top quadrants here to have a positive y value. And since I am dealing with the y's, I have 1, 2, 3, 3, 2, 1. And so I know my 1/2s are going to be 1 away. So once again, I am able to figure out, okay, what are these values? And I know it goes 30, 45, 60. all the way around. So 30, my first one will be 30 degrees over here off to the right. I know my other one here is 30 degrees away from 180, so I can take 180 and subtract 30, which will give me 150 degrees. All right, let's take a look at cosine. So cosine is our x value, and this is when x equals 1. So the nice thing about that is the only places where anything equals 1 will be on the axis. Now, since it is positive 1, not negative 1, I only have one option to choose from. But we do have to remember, this is 0 degrees, and then if we go all the way around, it's 360 degrees. So I still have two different options to choose from there. Just we have to remember it's 0 because that's where you start, and then 360 because that's where you go all the way around. All right, let's try a few more examples. So 6, we have tangent of x equals -1, so remember that is sine over cosine, which will be y over x. Since we have a negative number, I know that one of my values has to be negative. So either x or y, but definitely not both negative. So what that means is I cannot be, so they can't be both negative or both positive. Sorry, I knew I was missing one. So it can't be in quadrant 1, and it also can't be in quadrant 3. So I know I'm dealing with quadrant 2, so over here, in quadrant 1 there. Another thing that points out to me is that it equals 1. So that means when I divide, right, so when I divide, I was going to do 2 over 2. That equals 1, right? So they have to be the same thing. And if we remember, 45, 45, 90 triangles, that's the only one where they're the same, right? Because it's root 2 over 2, root 2 over 2. I just realized I drew that other one in the wrong quadrant. So that's going to be the same thing down here. Sorry, I wrote those ones in the wrong quadrants completely. So I have negative root 2 over 2, positive root 2 over 2. And then down in my fourth quadrant, we'll have a positive root 2 over 2, negative root 2 over 2. So I know it's going to take a little bit to remember these, but if we continue to draw them out and take a look at what they have in common, it's going to make some of these really nice as we start trying to memorize this. Okay, so I know that it has to be the 45, 45, 90 in either of these two quadrants. So that means I'm going to have 135 degrees. So if we take 90 and add 45 for that one. And then for my bottom one here, I can take 360 and subtract 45. There's a couple different ways that we can figure out what those degree measures without having to look at the other pages. All right, let's take a look at cosine. So cosine is x. I see that I have a negative, so it has to be a negative x value, which will be over here off to the left of my quadrants. And cosine, since that is x, I know that it's going to go 3, 2, 1, 1, 2, 3, 3, 2, 1. And I have root 3. So therefore, that's the 1 away, so that means that is 30 degrees from either side. So that is 180 degrees right here. So if I add 30 and subtract 30 from both of those, it will give me the values I want. So that top one will be at 150 degrees, and the bottom one will be at 210 degrees. Okay, let's take a look at sine. So we have sine, which is my y value, and it's at 1. So we have axis, and positive y is just going to be up there. So we only have one option here, which is 90 degrees. All right, and then our last one, we have tangent. So remember tangent, sine over cosine, which is our y over x, and it's at 0. So that means I also has to be on one of the coordinate points. So therefore we have 1, one of these values here. Remember we talked about a little bit earlier in the notes, the 90 and the 270. So these two values are undefined, so therefore we cannot use those ones. But we can use the left or right because it will be at 0, either at 180 or at 0, as well as 360. So remember this point over here is 0 and 360 degrees, and this point over here is 180. I was about to put 90. So 180 and then 0 and 360. All right, I know that was a lot of information. Please be sure to watch, try some examples, ask your teacher as you go along, and just work through trying to memorize the unit circle. All right, and I hope you have a wonderful day, and I will see you guys later.